Hello everyone. The title of this video is Writing Equations of Ellipses Not Centered at the Origin in Standard Form. So in this video I'm going to be going over examples that are taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 12.1, called the Ellipse, and I'm under the heading Writing Equations of Ellipses Not Centered at the Origin, of course in standard form. And the examples you're going to see in this video are going to be either examples taken directly from the reading, or one of the try it problems from the reading, or one of the exercises at the end of the section that's related to this particular objective. Okay, so hopefully you recall the equation of an ellipse that is centered at the origin in standard form that was further up here. And I also covered this in my last video on writing equations of ellipses in standard form. So the only thing that changes is the center for this video. Instead of the center being at 0, 0, we replace x with x minus h and replace y with y minus k, and that'll cause some sort of vertical and horizontal shift, and the center will be at a point called hk. Right, so that's what we've got here. So the standard form of the equation of an ellipse with center h comma k, right, h is the x coordinate of the center, k is the y coordinate of the center, and major axis parallel to the x-axis. So we're going to have two cases, just like in the last video. One where the major axis of the ellipse is parallel to the x-axis, or is horizontal, and the other case where the major axis is parallel to the y-axis, or is vertical. So in either case, you're going to have some term with the quantity x minus h squared divided by some number, plus, and then a quantity with y minus k squared divided by some number equals 1. Now when the major axis is parallel to the x-axis, underneath the x term, x minus h squared, you have a squared. And underneath the y minus k squared term, you have b squared. And this a and b mean exactly the same stuff as in the last video. So again, I'm going to be assuming here that you've written equations of vertices of ellipses centered at the origin before. A represents the distance from the center to a vertex, or the length of the major axis is just twice a. B represents the distance from the center to a co-vertex, or you could also think of this as the length of the minor axis being twice b. And they give you coordinates of the vertices, coordinates of the co-vertices. And then there's this number c that shows up once in a while. Remember those two foci. Again, I'm assuming you saw my last video for this on writing equations of ellipses centered at the origin. C represented the distance from the center to a focus, and there were two of them, right? Two foci. And the foci were always on the major axis, right? So on the same line as the vertices. And you needed to use this relationship here. There was this relationship between C, A, and B for all ellipses. C squared is going to be equal to A squared minus B squared. Right. And then the only thing that changes when the major axis is parallel to the y-axis is the A and B switch. You have A squared under the y term and B squared under the x term, and all the rest of it's pretty similar. And then here are some pictures of ellipses on the xy plane, and yeah, again, all very similar to pictures from earlier, but instead of the center being 0, 0, the center is shifted to hk. So it's shifted right or left h units, and then up or down k units. Alright, So, like in the last video, the examples I'm going to do, we're just going to be given information about an ellipse and asked to write the equation of that ellipse in one of those standard forms. So let's do that. All right. So my first example, example 1, and write the equation of the ellipse in standard form. All right. So the vertices, and remember these are the ends of the major axis, are at -2, -8, and -2, 2. And the foci, or the focuses, the foci, are at -2, -7, and -2, +1. Right, I accidentally wrote -1. That's +1. All right, so I'll start drawing some stuff. And we'll take a look at a rough sketch by hand, and then I'll go to that desmos.com free online graphing calculator to look at a better picture. So -2, -8 is one of the vertices. All right, so that's an actual point on the ellipse. It will actually satisfy the equation I end up writing. And the other vertex they gave us is at -2, 2. So right here, that's also a point on the ellipse, right? So we have a vertex here, vertex down here. And so it's clear to me then that the major axis is vertical. And if the major axis is vertical, parallel to the y-axis, then we're going to be writing the equation in this form: x minus h squared over b squared. Right, the smaller denominator is going to be under the b squared, under the x, plus y minus k squared over a squared. Right, the larger denominator, the a squared, is going to be under the y term, because again the major axis we notice is vertical, equals 1. And h and k are the coordinates of the center now, right? So we need to figure out where the center is, but that's going to be pretty simple if you know both vertices or both foci or both co-vertices, because the center is going to be in the middle of everything, the midpoint of everything. All right, and then I'll label where the foci are as well. We have -2, -7 is where one focus is. Now I'm putting this in a different color because it's not actually a solution to the equation. Remember, the foci and the center are not actually on the ellipse. So there's a focus. And then -2, +1 was the location of the other focus. And not on the ellipse. Alright, so to find the center, this is just the midpoint. And you should, finding the midpoint of a segment is pretty simple. This is the midpoint of the major axis or the minor axis, but major axis or minor axis, or the two foci. I mean, if you know the two foci, you can also say the center. So very easily, now I hope it's obvious. Remember that the x-coordinate of the center will be -2. And so the value of h is going to be -2, so I'm going to have x minus -2 or x plus 2 in the equation. And then the y-coordinate, again, just halfway between these, halfway between 2 and -8, that's 10 units apart. They're 10 units apart, so if I go 5 units to -3, that'll be where the midpoint is. Or you just take the average. Remember, this is the average of the x-coordinates, the average of the y-coordinates. That's the midpoint. -8 plus 2 is -6, and then divide by 2 is -3. All right, so the value of h is -2. The value of k is -3. So here's -2, -3. There's the center. All right, -2, -3. The h and the k. That will go into my equation. All right, and now that I have the center, I can tell you the values of A, B, and C, or I want to eventually find A and B to be able to fill in this equation. So remember the distance from the center to a vertex. Right, the distance from the center to a vertex, that's A. And that's here, 5 units. Right, that's 5 units here. So the value of A is 5. And the distance from the center to a focus, right, so to one focus or the other focus, that was called C. And we're going, that's 4 units. Right, from -2, -3 to -2, -7, or -2, -3 to -2, 1. That's 4 units. So A is 5, and C is 1. Or sorry, 4. Jeez, just said 4. Right. So the distance from the center to a vertex is 5 units. The distance from the center to a focus is 4 units. And then we can use that relationship between C, A, and B for any ellipse, that C squared is going to be equal to A squared minus B squared. We're going to use this relationship to find B. And then once we have H and K and A and B, we can fill in everything we need to write the equation of our ellipse. So C squared is going to be 16, right? That's 4 squared. A squared is 5 squared, that's 25, minus B squared. And then we solve for B. So B squared is going to be 25 minus 16, that's 9. So B is 3. Right. B is 3. And the major axis is vertical, meaning the minor axis is going to be horizontal. So I can get the co-vertices from this as well. I know they're not asking for them, but I'm going to write them anyway. Remember, you're going from the center, and I'd be going to the right and left 3 units. So to the right 3 units, from -2, -3, that's this point here at 1, -3. Right? One of the co-vertices is at 1, -3. And the other one, again, from the center, I go to the left B units, left 3 units to -5. Right, -5. And there's, the other co-vertex at -5, -3. Right, I just added and subtracted 3 to the x coordinate of the center for those co-vertices. And then once you have the vertices and the co-vertices, right, you should be able to make a rough sketch of the graph of the ellipse. Right, this oval shape. All right, something like that. Another thing too is, if you remember from last video, what's so special about the foci is that if you were to take any point on the ellipse, any point at all on the ellipse, take the distance to one focus, call that D1, and then take the distance to the other focus, say I call that D2, and add them up, it's always going to be the same number. In this case, it's going to be 10 all the time. It's just 2a, the length of the major axis. So if you did that, take any point on the ellipse, take the distance to one focus, add the distance to the other focus, it's always going to be 10. Alright, but again, that's not important either. That's not what I'm trying to do here. I'm trying to write the equation of the ellipse in standard form. So the equation of this ellipse is x, minus h, x minus -2, so it's x plus 2 squared, right, divided by b squared, right, b squared was 9, plus, and then the quantity with y minus k, y minus the y value of the center, it's y minus -3, but y minus -3 is y plus 3. So you have y plus 3, that quantity squared, divided by a squared, which is 25, equals 1. And this is what we wanted. There's the equation of this ellipse in standard form. Right. And now what I'm going to do is make sure that it matches, right? It's correct, that it has these vertices and these co-vertices and all that. Right? So I'm going to go to that Desmos website, desmos.com, a free online graphing calculator, and type in the equation I just wrote. So we have the quantity x plus 2 squared divided by 9 plus the quantity y plus 3 squared divided by 25 equals 1. And you see this ellipse showing up. And if you click on this, right, you can see the tops of hills and bottoms of valleys are shown. That would be the vertices. See negative 2, 2, negative 2, negative 8. Those were the vertices that were given to us. You can very clearly see that the center is at negative 2, negative 3. And I'll plot that point. All right, hopefully you see the center here, negative 2, negative 3. And you see how 3 units to the left, negative 5, negative 3. That's one of the co-vertices. And then 3 units to the right, 1, negative 3, another co-vertex, which is exactly what I wrote on my paper. So, looks good. Looks like they match. Great. And this is pretty much what I'm going to be doing for the rest of the video. Right? Looking at some information about an ellipse or maybe a graph of an ellipse that's not centered at the origin. Find the center and find the value of a and b. You just need to find the center, the h and the k, and then somehow find the value of a and b, and you should be able to fill in the standard form of an equation for an ellipse. All right, so I have a pretty similar problem on the next example. All right, example 2. So once again, I'm given the vertices and the foci. And I'm asked to write the equation for this ellipse in standard form. Alright, so I'll start drawing a picture, make a rough hand sketch, and then we'll take a look at a better picture in Desmos when we're done. Alright, so the vertices are at negative 3, 3. So there's one vertex, and that's actually on the ellipse, right? That's actually satisfying the equation I'm going to write. And the other one's at 5, 3. So 5, 3. So the center should be at 1, 3. Right? That's exactly halfway between these. Negative 3 to 5 is 8 units. Half of that is 4, so I need to go 4 units away, right? The middle. So the center we can figure out is going to be at the point 1, 3. And there's the value of h and k that are going to go into my formula. They're going to go into my equation. Now also, see how the vertices are on a horizontal line. Right? The major axis is horizontal this time, sorry. The major axis is horizontal. It's parallel to the x-axis. And if that's the case, the equation we're going to fill in is this one. X minus h squared. This time a squared is under the x term. All right. Plus, and then y minus k squared divided by b squared equals 1. And again, I have the h and the k, so we're going to have x minus 1 squared and y minus 3 squared in my equation. And I just need to find the a and the b. That should be b squared. All right, now the foci are at 1 plus the square root of 12, 1 minus the square root of 12, comma 3. Right? 2 root 3 is the same as the square root of 12, which is between 3 and 4 units. So somewhere between 4 and 5 here is one focus. Right there, I'll just put F1 for focus number 1. That's this one here, the 1 plus the square root 2 root 3, comma 3. There's 1 plus 2 root 3 on the x-axis. And then same thing from the center, I go to the left, 2 root 3. That'll be between negative 2 and negative 3 here. So let's say that's around here, right? 1 minus 2 root 3. And there's the other focus, F2. Well, I'll call this one F2. Alright, so I got the two foci there. And then just like in the first example, I have the center, I have the vertices, I have the foci, so I know A and C. Alright, the value of A is the distance from the center to a vertex, which would be 4 units. And the value of C is the distance from the center to a focus, which is going to be 2 times the square root of 3. Right? Or the square root of 12, if you want to think of it that way. So I know the value of A and C, and then once again to find the value of B, I'm using this relationship, C squared equals A squared minus B squared. This is the case for all ellipses. Now, this squared would be 4 times 3, again that's 12. A squared would be 16 minus B squared, and then we solve for B. Right. So B squared would be 4, right, 16 minus 12, and then B must be 2. So the co-vertices, we have the vertices. I could tell you what the co-vertices are now. And the vertices are left and right of center, so the co-vertices are going to be above and below center. I'm going up and down 2 units. So if I go down 2 units, that would be the point 1, 1. Right, and all I'm doing is subtracting 2 and adding 2 to the y coordinate of the center. So one of the co-vertices will be at 1, 1. That's when I subtract 2 from the y coordinate of the center, and then when I add 2, it would be at 1, 5. 1, 5. And then once I have the vertices and the co-vertices drawn, I should be able to make a rough sketch of the ellipse. Something like this. Again, it's not perfect, not a great hand drawing. And now my equation. And just h is 1, k is 3, a is 4, and b is 2. So we have x minus 1 squared divided by a squared, which would be 16, plus y minus k squared, so y minus 3 squared, divided by b squared is 2 squared, which is 4, equals 1. And there we have it. This is what they're asking us for. And once again, I'll check it out, just make sure all the information is proper, right, that the vertices and co-vertices I have written are correct for this equation. And you can also plug in these values. The vertices and co-vertices are actually on the ellipse. So if you plug in those x and y values to the equation, it should make it true. So let's check it out. So again, we have the quantity x minus 1 squared divided by 16 plus the quantity y minus 3 squared divided by 9. Nope, divided by 4. I'm actually reading the wrong thing. Equals 1. All right, and this is our ellipse right here. See, the co-vertices are at 1, 5 and 1, 3, or 1, 1. The center should be at 1, 3. If I plot the point 1, 3, there it is there. And then remember, A was 4 units, right? 4 units to the right, there's 5, 3, one of the vertices they gave us. And then 4 units to the left, there's negative 3, 3, another vertex they gave us, right? So this has all the proper information. This is a good graph, good equation. All right. So another one like this. All right, so in this one, example 3, I'm actually given the center. Right, the center is 3, 5. Right, so there's the h and the k for the formula. But we're only given one vertex and one focus. But you can use symmetry to find the other vertex and the other focus pretty easily. Right? Remember, these ellipses are symmetrical about the center. So if something's 5 units to the right of the center, it's also going to be, there's going to be another point 5 units to the left of the center, and so on. So I'll start making a drawing here. So yeah, the center is at 3, 5. And now that's not actually a point on the ellipse, right? The center, the foci, those don't actually satisfy the equation. They're just more like guides. And then one of the vertices is at 3, 11. Right, so there's a vertex. Now if there's a vertex at 3, 11, then there's going to be another vertex at 3, negative 1. Because look, this is 6 units here. And that would be the value of A. Right, from 5 to 11, that's 6 units. So the value of A is 6. Right? And if we have a vertex 6 units above the center, through symmetry you'll have a vertex 6 units below the center. So that'll be at 3, negative 1. Right? So there should be another vertex at 3, negative 1 as well. All right, and then for the foci, again, from 3, 5, see how they're just adding 4 times the square root of 2, which would be the square root of 32, right? Square root of 16 times the square root of 2, square root of 32. So they add the square root of 32, and then you should also subtract the square root of 32 from the y-coordinate of the center and get the foci. Now the square root of 32 is between 5 and 6 units. So somewhere in here, here's 5 plus 4 root 2. And then between 0 and negative 1, there's going to be 5 minus 4 root 2. There are the two foci, very close to the vertices. I put them in little red dots. So yeah, the other one will be at 3, 5 minus 4 root 2. But the value of C then is 4 root 2. Right, that's square root of 36, square root of 32. 4 root 2 gets added and subtracted from the y-coordinate of the center to get to the foci. So the distance from the center to a focus is 4 root 2. Alright, so once again, I have A, I have C. The major axis is vertical again. Right, the vertices and foci are all on this vertical line. The major axis is vertical again, parallel to the y-axis, so that means we're going to have this kind of an equation, x minus h squared over b squared. Right? This time the a squared is going to be under the y term, because the major axis is vertical, plus y minus k squared over a squared equals 1. And I know h, I know k, I know a, I just need b now. And that's where that relationship comes in again. C squared equals a squared minus b squared for all these ellipses. C squared will be 32. Right, 16 times 2. A squared is 36. And then we solve for b. And again, we're seeing that b squared must be 4. So b must be 2. Alright, so I can tell you, they didn't tell us, but I can tell you what the co-vertices are then. I'm just two units to the right and left of the center. Right? The minor axis will be horizontal if the major axis is vertical. So the center's at 3, 5. If I add, I'm just going to be adding and subtracting 2 to the x-coordinate. So 5, 5 should be one of the co-vertices, and 1, 5 should be one of the co-vertices. Right, 2 units to the right of the center, 5, 5. 2 units to the left of the center, 1, 5. And now that I have the vertices and co-vertices in, I can draw a rough sketch of the ellipse like this. And again, not perfect looking, but we'll take a look at it in Desmos. And now that I have h and k and a and b, I can write the equation. So we have the quantity x minus 3 squared divided by b squared was 4 plus, and the quantity y minus k, so y minus 5 squared divided by a squared is 36, right, equals 1. Sorry about the tightness of this on the edge of the page there, but there's equals 1. And there we go. That should be the equation for the ellipse they described to us. All right, and once again, I'll go to Desmos. We'll take a look. I'll just refill stuff in this. So x minus 3 squared divided by 4 and then y minus 5 squared divided by 36 equals 1. There's the ellipse. Right now I'm going to get rid of this 1, 3 point, right? So here's our ellipse. The center should be at 3, 5. Looks pretty good. And you see if I go 6 units up, there's a vertex at 311. 6 units down, there's a vertex at 3, negative 1, exactly what I had labeled. And then B was 2, right? So 2 units to the right, there's 5, 5, right? One of the co-vertices. 2 units to the left, there's 1, 5, one of the other co-vertices. And again, you can plot the foci if you want, but I'll leave that to you. But the foci should be on the same line with the vertices, right? Should be on the major axis all the time inside the ellipse, right? If you graph the foci and they end up outside the ellipse, then something went wrong. You did something wrong. Go back and check your work. Okay, great. And I've got this one final example here. Now this is actually going from an exercise in the text, so I'll go back to the textbook. I want to do exercise 56, where I believe they just give us a graph. Right? So if I scroll down to the end of the section where the exercises are, exercise 56, yeah, we're given a graph and asked to write the equation. Right? So, and based on where the vertices look and the co-vertices look, we should be able to easily write an equation for this. So I'm going to draw a rough sketch of this picture on my paper. All right, the vertices look like they're at negative 2, 3. Not doing units here. Negative 2, 3. And at the other end of the lawn of the ellipse was the point. It looks like the point 4, 3. All right, so vertices are at negative 2, 3, and 4, 3. And then the co-vertices look like they're at 1, 2, and 1, 4. 1, 2, and 1, 4. So something like this, right? This was something like the ellipse picture we were given. Very crappy looking. But the co-vertices are at 1, 2, and 1, 4. Alright, so I'm hoping it's obvious where the center is. Right, again, it's the midpoint of these two, or the midpoint of these two. It should be at 1, 3. Right, the two ends of the major axis are 6 units apart. So cut that in half, go 3 units in. That'd be at 1, 3. Right. The center's at 1, 3. So there's H and K. And then A is the distance from the center to a vertex, which is 3 units. Right, from 1, 3 to 4, 3 would be 3 units. And then the distance to a co-vertex is 1 unit. That's B. A equals 3. B equals 1. And the major axis is horizontal this time, right? The long way, it's longer horizontally than it is vertically. The major axis is horizontal, is parallel to the x-axis, meaning our equation is going to look like this: x minus h squared over a squared plus y minus k squared over b squared equals 1. And I have everything. Replace h with 1, k with 3, a with 3, and b with 1, and we have the following. The quantity x minus 1 squared divided by 9, right? A is 3, so a squared is 9, plus, and then y minus k squared, y minus 3 squared. Now divided by 1, usually people don't write divided by 1, because b squared would be 1 here, so I'm just going to leave it like that, equals 1, and there you go. Okay, and then we can put this into our Desmos site and see if it actually matches what this graph looks like here, and it should. All right. So we had x minus 1 squared divided by 9 plus, and then y minus 3 squared. Y minus 3 squared divided by 1. So let's get rid of that, equals 1. There you go. See, centers at centers at, do this. Centers at 1, 3. Hopefully that's obvious. You got 1, 2, and 1, 4 as co-vertices, and then 4, 3, negative 2, 3 as the vertices like I labeled here. This is exactly the same picture that they gave us here. It's exactly the same ellipse as in the assignment. So this equation is good. Alright, and that's really it. Alright, that's all I've got for you here. So I'm hoping that watching me do these 4 examples here helps you in some way when you're asked to write an equation for an ellipse not centered at the origin in standard form on your own. And thank you very much for watching.